We are asked to graph the inverse of this function. Now notice that it's a linear function, so it's 1 to 1. So it does have an inverse. Let's graph this function first because we want to graph both of them. So what do you know? It's in the form that we like, right? Y equals mx plus b. So b here is the y-intercept. That's -1. So I'm going to go to -1 and plot a point. I'll plot that point right there. And then, what do I know? The slope is 2, right? So out of this, I'm going to get here that the slope is 2, but slope, write it as a fraction. So what I'm going to do is from that intercept, I'm going to go to the right one, up 2. Now that's pretty tight, so to the right one, up 2, because they're positive. So I'll do it a couple of times. To the right one, up 2 puts me right here. Plot that point. Now I'm going to do it again, so I can draw a better line through that. So from here, I'll go to the right one, up 2. Plot another point. To the right one, up 2. I'll even do it one more time. So from here to the right one, up 2. To the right one, up 2. Now I'm going to pass a line through these 4 points. I think that's a pretty good line. All right, so this is the graph of 2x minus 1. Now I want to graph the inverse of this function right here. So there's a couple ways I could do this. First of all, I could just go through our process, replace f of x with y, interchange, and solve, and I'll do that momentarily. Or I could do this. I know that the inverse I can get just by interchanging the x and y components in that of those ordered pairs on the line. So look at these ordered pairs. Now I'm just going to write them as I see them, starting from the bottom left going up. So what do you get here? That's a 0, -1. Right, so I get 0, -1. Now interchange. -1 and 0, right? Because it's an inverse. 0 goes to -1, so an inverse, -1 would come back to 0. Now let's get the other 3. I'll just move from left to right up that line. So the next one I'm at 1, 1, and when I interchange those for the inverse, no difference. 1 goes to 1, so 1 goes to 1. The next one up, looks like it's from the origin, over 2, up 3, over 2, up 3. Now interchange them for the inverse, over 3, up 2, right? What it's saying is that a 2 processes into a 3, so to go back, undo, 3 goes back to 2. And then finally the last one is a 3 goes to a 5, so the inverse is going to take a 5 back to a 3. Now let's plot these points. So I'm going to just plot these points over here. So -1, 0. -1, 0 is right there. I'm going to do it in a different color here. -1, 0 is right here. And then I'm down here at 1, 1. Oh, okay, well that's going to be that same point that we already have right there. Then over 3, up 2, so over 3, 1, 2, okay, over 3, from the origin. 1, 2, 3, up 2, right there. Over 3, up 2. Yeah, it looks like those are falling on the line. And then over 5, up 3, right there. Yeah, it looks like they lie on a line. So let's pass a line through those points. Here it comes. There it is. All right. Now what I've got here, this is F. Oh, yellow's not a good color. That's F inverse. And let's look a little bit more closely about what's supposed to happen. Do these lines look to you like they are reflected right about that 45-degree line? Now I'm going to draw a 45-degree line in here. Here's that 45-degree line, or the line y equals x. I'll put that in as a dashed line. So we know that inverses are reflections about this line y equals x, so the 45-degree line. Now, you have to use your imagination here, but does it look to you that if you took this curve and just reflected the whole thing around that line like that, if you took that red curve, that you would end up with that green curve, or the red line to the green line? Sure looks like it. So I've got the graph. Now I can actually get the line if I just do this, right? Go back to our process. Replace f of x with y for convenience. Y equals 2x minus 1. Interchange x and y. So just interchange them. I'll get x equals 2y minus 1. Let's add the 1. We'll get x plus 1 is 2y, right? 2y. Now I'm going to divide by that 2, but I'm going to divide every individual point by 2, individual term by 2. So there's a 1, divide that by 2, I'll get 1/2 x plus 1/2, and now give y its new name, which is f inverse of x is 1/2 x plus 1/2. There's the inverse of that function. You know what? Let's test it out here. What if you graph this? Where's across the y-axis? At 1/2. Ah, that looks, can you see it there? Does it look to you like it's 1/2? Close enough on my picture. And then the slope is 1/2. So from that point, we're going to go to the right 2, up 1. So starting there, to the right 2, up 1, we're back on the green line. I think we've got it.